engineer and research computing at Purdue University. So today I'll be talking about our work integrating HUBzero and iRODS in service of a collaborative research environment with a special focus on geospatial data. So I think it's actually a happy coincidence that I'm going after Nero because most of the things that we're trying to do is pretty similar to what they have. I'm also pretty young project, so I think we have a lot of learn from them. Yeah, I'll just get started and I guess that's where it goes. So I think this is going to be a longer presentation. I'm going to be doing slides hopefully for the first half. I'm not bore you too much, and then I'll be switching over to a demo. That should be exciting. Let's see how that goes. All right. So first, some history. So over the past few years at Purdue, we've been involved with a couple of research projects. So I have a couple of names there. So GeoShare, branded and UPU, and the big thing about these projects was that it involved people from around the world, so they were researching around the world, and also researchers from different scientific domains. So we had people from hydrology, from climate sciences, environmental engineering, agricultural economics, and so on. And still there was this common theme. So you had researchers who wanted to share their data with each other. So you had people, say, in crop research institutes in India and Africa who had real-world crop yield data for a particular year, and you had these climate scientists in Canada and the US who were building these research models that were trying to predict crop yields or the effects of climate change on crop yields. And so this is a very simple picture. So we had researchers around the world trying to share, in particular, geospatial data. So that's sort of our theme here. So they had geospatial data from around the world that they wanted to share with each other, and many of them had their own modeling tools, or they wanted to use tools that were built by other researchers. And so there was this big cycle. We had researchers transmitting data, running processing tools on that, and then getting the results back and then sending it back to the other and so on. And so there were a couple of broad goals in these different projects. The first thing was, of course, to share and manage and query data that people had put up somewhere. And of course, research collaboration, and there was a need to preview data. So geospatial data usually is a lot more intuitive if you have it put on a world map, so it's a lot more easy to figure out what's going on. And because some of these scientists do not really have an intuitive understanding of different geospatial data formats and so on, so it was always helpful to have actually be put on a map so that you could see the trends across regions or the trends across time scales and so on. So there's a need for quick preview of geospatial data. There's also a need to run these post-processing tools, as I mentioned before. And again, there's a need to compare data from different sources. So you had someone say, calculating the crop yields of like maize or rice in a certain region. You had people who had built models to sort of figure out the same thing, and you want to compare data across those two things. So, of course, because of this distributed nature, we wanted to have a web framework that people would actually go into and then do all these operations on that particular platform. So we wanted to have a web framework that people could put the data on, people could put their tools on, and then hopefully contribute towards research. And so the framework we use for that is called HUBzero, which is essentially a cyberinfrastructure platform that was built at Purdue. And it has a couple of capabilities. So the first thing is, of course, user collaboration. So you can actually go in there and build user groups. You can set up projects that you can invite other people, invite other team members to, and you have message boards that people can use to each other and so on. And the second big thing was it supports instruction. So you can actually have people set up courses, tutorials, and lecture slides and so on. And you can tie it to the actual live tools that you have on the hub. So you have tools running on the hub. You can have your live experimental data that you attach to those tools, and then have students go in and use that in real world examples or okay. So it's very useful instruction as well. And finally, and I guess sort of the main theme here, is data sharing. So these different project spaces in these groups sort of function as collaborative spaces, so you can have people set up a project and then go in and put files there or put data and share it with other people. And eventually it leads to publications. So the data that you have sort of worked on and you figure that it's pretty good and you run tools on it, you have a very interesting result, you can bundle all that data together and then generate a DOI or a physical object identifier for that particular data set, and then you can actually cite it in your publications. So that was the HUBzero framework that was already there before, and so we were just able to sort of use that and then apply it to these different projects. And just a brief history of HUBzero. So HUBzero started off as this single monolithic website which is focused on nanotechnology, so it's called nanohub.org. And we sort of abstracted the framework, the core framework from that website, and then turned it into the HUBzero platform, which is then used across all these different fields. So it's used in medical research, in materials and manufacturing, and HPC, of course. So it functions as sort of like a scientific gateway towards all HPC resources, both at Purdue and NXE, and education and outreach. So it's essentially the cyberinfrastructure platform that allows users or people to come together and then collaborate on research problems. But then the big thing that HUBzero provides is the notion of hub tools. So hub tools are essentially scientific tools that sort of run natively on the browser. So you have this Rapture toolkit that allows people to quickly mock up tools which have essentially GUI elements added to it. So if you have some piece of scientific code that doesn't really have a GUI attached to it, then you can come into the hub, you can have your actual code that's there, but then it requires a sandbox environment where you can add input elements like drop-down lists or choices and so on, and it has a couple of output elements as well. So you can have visualizations, you can have things for displaying videos, graphing programs, and so on. So you can sort of plug in your scientific code into this framework and then just add this GUI around it. And they all run in OpenVZ containers, so you can actually just go to the hub website, you can start the tool, it launches a container for you, and everything just runs on the browser. So you don't have to actually send your code over to someone else or have them compile the dependencies and so on and so forth. So that was pretty helpful in these 3 different projects that I talked about before. And the data transfer was there essentially before with HUBzero was just from your local desktop, so you can download files to your local desktop from the tool session or upload files from your local machine to the tool. All right, so in the course of working on these 3 different projects, there were a couple of things that we kept running into. So essentially, since geospatial data was this big part of these different projects, we kept having to build things for processing geospatial data. So common operations like resampling the data to fit a particular resolution, or reclassifying it, so essentially trying to reduce the, I would say, the number of dimensions, so essentially trying to classify it into smaller classes, and extracting metadata from all these different files. So geospatial data is typically very structured, and so you can often get a lot of metadata just from the file itself. And it's usually preferable to have that extracted automatically rather than have someone go in and then extract on their own, because there's potential for mistakes, and people don't really want to do that if they've just created a tool that sort of does everything before. And then, of course, I talked about this map visualization, so you want to be able to preview your geospatial data in the map. And, of course, search is also. So you want to be able to go to a certain location, and then you want to know what kind of data exists for this particular location, what can I use in my different processing models. So you want to be able to search for data that matches a certain geospatial region. So the GABBS project was sort of designed to build a common framework that provides these different operations that can be reused across different projects. So GABBS stands for Geospatial Analysis Building Blocks. And our hope was to build these different pieces, but then be able to use it across any new hubs that we come up with or any new services that we want to provide to other applications outside of the HUBzero framework. And it's part of the NSF DIBBS initiative, where DIBBS is essentially data infrastructure building blocks. And the main theme or the main goal of the DIBBS initiative was to allow data sharing to be used as a part of collaborative research, a form of basic collaborative research, and also to support diverse domains. So that was part of our challenge. Initially, we had people from these different diverse domains who were not really familiar with the different geospatial formats, and so we wanted to be able to sort of reduce the barrier of entry. So here's a brief picture of the GABBS architecture. I'm not going to go into much detail. I just stole it from someone else. So there's the HUBzero platform right at the end at the bottom. So GABBS is sort of built to be installed on top of a basic hub, so it's built on top of HUBzero. At the top you have the different operations that we are trying to support, so computation, visualization, and data sharing of geospatial data in particular. And we had to build all these different capabilities into HUBzero to sort of support all that. And you can see that a common theme there is data. So if we look at a closer picture of how data is really working in GABBS, so we have data at the center, and you have all these different things that need to happen on top of the data. So you have hub tools that need to process and transform the data. You want to be able to share the data with other users through the HUBzero projects. And groups framework. And you want to be able to visualize it and also annotate and extract metadata automatically. And you can see that there were a couple of things that were sort of broken, and there are a couple of shortcomings in the HUBzero platform that we're trying to solve. So first thing is the Hub tools, as I said before, get the data from the local desktop and then get it uploaded back from the local desktop. So there's no common access between people who are coming in and then sharing their files in the project's file space and the Hub tools that are actually running on the Hub directly. So even though both of them were directly installed on top of the Hub, there was still no common access between the two things. And again, once you had data that was generated from these different processing tools, it used to go back to the storage, but then there was no process that was automatically extracting the metadata. And most of these tools that are built add a lot of metadata on top of their files because they want to really have important information stored in their outputs. And so that process was not automatic. And so iRODS sort of helped us bridge those gaps. So this again is just going over the kinds of things that we were discovering that was not really covered with the HUBzero and our GABBS integration initially. So we wanted a central storage mechanism that could be applied across all these different pieces, all these different operations that were involved with geospatial data, but then eventually be able to support larger files. So right now, the files that we handle are pretty small. It's like a couple of hundred MBs and so on. So it's not really large files yet, but then eventually we want to be able to support that. And the other big thing was we wanted to support processing of these files to be co-located with the data itself. So we didn't want to have to transfer the data from one location to the other, or run processing somewhere else, pull it in from iRODS and run somewhere else, and so on. So we want to have processing co-located with the data. And we also wanted to be able to package this easily. So GABBS, the main focus of GABBS is these reusable components, so we wanted to be able to have something that was easily packageable and then distributed with other people. So the main thing that we did was we changed the Hub project file space to essentially be based on iRODS. So every Hub project now gets a collection that's built in iRODS, well, a collection that's created in iRODS, and then all the files that you upload to your project's file space go to iRODS. And rather than use the various iRODS APIs, we used the FuseMon, and I can see people wincing at that. I guess Jason's probably wincing at that. So we used the FuseMon. So we mounted it directly onto the web server where the Hub is installed, and you can just access it directly as just like a local file. So the Hub is built on PHP, so we just use PHP file APIs to do that. And the other big thing was, in order to have that common access between Hub tools and Hub projects file space, whenever a new tool container is started up, we mount some of the collections from your Hub web server onto the tool container. So you have a FuseMon in your Hub web server, and you have individual collections for the different projects. And so when the user starts a tool, we find out what projects that he's a member of, and so just the projects that you're a member of get mounted into your tool container using the BindMount solution. So essentially we just mount parts of the file system onto your tool container. And so that immediately solves a lot of our problems, because people now can just directly use that as the input source for the files. So files that have been uploaded into the project space can just get pulled into tools, and they can just write files back to the project's file space, and they just automatically appear in the projects. And you don't have to do anything to your tool source. So that's the best part of all this. And the other big thing was in support of the two other operations that we had, so visualization and metadata. So we built a couple of microservices that sort of work on these different policy enforcement points, and they automatically extract metadata from these geospatial files. So you have GDAL, which is a pretty familiar library, and so that's used to extract metadata when a new file is registered, and it automatically extracts the metadata, stores it in the catalog server, and also sends it off to Solar for indexing. And in support of on-demand operations, so the user can actually go in, they can go into the project's file space, they can change any metadata that they want to add new metadata, they can do that. And so we have a couple of microservices for that as well, so you can update metadata in chunks, essentially you have a lot of metadata. And finally, visualization of geospatial files is again built as a microservice. So you have a couple of transformations that you need to do in any geospatial file. And the map server that we use is GeoServer, so it doesn't really handle all of the file extensions you can have, so we have to do a couple of transformations, and so all of that happens in microservices as well. So So here is just an updated picture of our setup. So we have iRODS there in the center, and we have FuseMod on top of project files, and any new tool container gets a bind mod of just the directions that the user can access. And both metadata and preview are essentially microservice calls to rules. Right, I sort of went over all this before, so just a couple more details. So first thing is the metadata extraction process, so that runs on basic post-prod for that most of you are familiar with. It uses GDAL to sort of process the file, extract as much as it can, and then it also gets the BOM so that we can use it in subsequent GeoSearch for files. The metadata storage, again, stores API triples and ingested in Solar for research. This is the metadata update that happens from the user interface, so from the HUBzero files interface. We can actually go in, we can change whatever we want, then we just create an array of key value pairs, send it off to the microservice, and then magic happens. Yeah, and then the hub is based on PHP, so we've been using a very small part of the PHP APIs for just that one thing. And Geospatial preview, as I mentioned before, again, we have a microservice that does that on demand, so it creates the necessary transformations. It registers a layer on the GeoServer, and then we can use JavaScript libraries to essentially preview the file and show it on the user interface. All right, just a couple of things about where we're headed. We have these different hubs that we are building, and so there's the scope to be able to use federation, so we can actually have tool workflows that start with one hub, push data on to another hub, but there's a tool so we don't replicate data or tools across different hubs. And that's the whole purpose of the apps. You want to have these blocks that we can use, but they're not really big most of it at the same time. Hopefully use federation to build tool workflows across hubs. There's also a plan to integrate other storage mechanisms into projects. Right now we just have basic get-based storage and iRODS as another storage choice, and we want to try to integrate other storage mechanisms as well, and hopefully try to pull in data offline from any other place that users can have data in. And this final thing, it came about when we were trying to use the FuseMod and the bind mods on some of our geospatial tools. We were saying that files which were like hundreds of MBs large were pretty slow, and they were trying to be accessed through these different geospatial tools, and so we're trying to integrate these common data access protocols. OpenDAP is a very famous data access protocol that allows you to subset these large geospatial files, which are structured in a way that allows this, and you can access just the parts that you're interested in. So we are actually working on adding that on top of our iRODS storage so that NIFA tools can use the OpenDAP protocol and sort of just get the data that they need rather than for a file at once. And I guess that is the end of my slides, so I just want to thank NSF again, which and DIBBS project which sort of made all this possible. And I think I'm going to go over to the demo, or I can stop for questions and then go. Oh, yes.
That's really nice what you've done. And the question I have for OpenDAP, which version of Fuse did you try?
We actually did the one that, the latest one, 4.1.8, which has the buffered file system on top of it. Well, the buffering for essentially.
Correct, yeah. So we had that, because we ran it with PyDAP and it worked for us. I don't know if there was some disconnect, and I'm happy to
we haven't integrated with OpenDAP yet, so we are actually working on that right now. So currently we just have the FuseMod and the bind mod, and the files are just accessed as a whole, not using OpenDAP.
No, but some of the FuseMod changes that we contributed back, the buffering, it also honors the open and fseek.
Okay.
And so it does buffer the file that you're trying to, so what the access pattern for OpenDAP is something that we have tested against.
Okay.
So if this is not working for you, drop me a note and we will go revisit.
All right, sure. Yeah, so the experiment we were trying was we had this huge NetCDF file that had like several sub-data sets. And so even with the buffering there, it was actually a lot slower than just trying to just get the metadata for that one sub-data set versus like the whole file. So we were hoping that OpenDAP would solve that. But yeah, I'll try it out right now.
Yeah, I think it's more of a Fuse limitation than open data that we're bringing in and everything.
Right. Thanks, Mark. Any other questions? No. Well, I'll try to do a really short demo and hope that everything works. All right. So this is my GeoHub is essentially the hub that we built to sort of showcase all our GABBS components. And you can see that the other projects have sort of been pulled into this one hub, so we have GeoShare trying and view in here as well. So once you've created a login here, you can actually go into your dashboard and it shows you all the things that you have access to. So you have like different hub tools that you have access to, your different groups, it has a ticketing system so you can submit tickets and have someone look into that. And you have a list of the projects that you're a member of. And so I'm going to go right here and start a new project. Once you get to your project, you have a couple of things here on the left-hand side. So you have a place for the files and databases, which is essentially the way to import CSV files into your project's file space. But the thing I guess that we're sort of most interested in is the file space. So if you come in here, if you come into your file space, you will have a list of all the storage adapters that have been added to the project. Right now we just have one master repository, which is GitBased, and that's used for your publications. So if you bundle the data set, it gets committed to your Git repository. It becomes a bundle that can be referred back to later. And then you have an iRODS connection here, so you can go in there, and it brings up a really traditional file browser interface. So you have all different files. So I can go ahead and go with a bunch of files here. I'm going to upload this GeoDiff file, which is essentially the yields of, I think it's maize or below. It's a very small file. It's going to take too long. Just going to open it back here. All right. So going back to my dashboard, I can go into the list of tools that are installed on the hub. So you have a bunch of tools here. And one I'm going to talk about is multispec. So this was actually a desktop tool that was built in like the late 1970s. And it had, I think, close to 1,000 users when we started this whole thing. And so we were actually able to put it up on the hub, I think, pretty painlessly, and it just took less than a week or probably just a couple of days. So it is a tool that allows you to essentially process and do various things on geospatial data and multispectral data. So you have, it was initially built for remote sensing data, so you have satellites that collect data in different channels, and this was used to sort of study the different channels and then split them up and take that. So, all right, my flow is done. So I can go in here, I can go to File and just open, and right now all the moms are in like a very unintuitive location, but we're hoping to change that. So if I go to /SRB iRODS, there's this new project that I created, which is iRODS GM. So there it is. And you can see there's the file that I uploaded in my file space, so I can just get to it from here. You can see open. And let's kind of do a bunch of processing, and it's essentially going to load up my image here. I could have also got into it from my file space here. So we have what's known as file handlers. So based on the file extension, you can actually set certain tools to be invoked directly on that particular file. So diff files, for example, have these different options. You can actually open it with multispec. So I can kill this tool session. You can go back in here and I can say I want to open this file with multispec. So that does pretty much the same thing, just sends a parameter to my tool session that tells it where the file is located, and then it just pulls it in that location. All right, so I can do a bunch of simple crossing operations on this. I've memorized all this, and I don't really know most of this, so I've sort of memorized what I need to do. So I can go in here, and someone who's really familiar with this data set can see that things are all messed up here. It doesn't really have the right bonds are basically have the right information encoded in here, so I can go here. I can fix that, so I can say it's on 9. Oops. Once I know geospatial concepts and have all that encoded into the file, I can actually overlay other files on top of this because then I can match the predictions. That's going to help. So once I have that set, I can select, say, a certain region. I can select, say, Africa. I can go in here and I can just save that section of the file to a separate file. So I'm just going to select the one channel. It's going to ask me where I want to save it, and again, I can just point it to the iRODS mount that's on here. So there's a iRODS engineering. All right. Save. Should take a while. All right, it's done. So I'm back here. I go back to my project, and I want to hopefully see the file show up there. So. Alright, it's there. Now the new file that was created in the tool session, and then it just appears on your project's file space. So if someone else is collaborating with you on this project, they can get to it directly from here. We have a bunch of menu options in the top here. So this one shows you the metadata that we've sort of extracted from the file. It's pretty sparse because there's not really much on the file, but then the main thing is we've got all the geospatial bounds in here. And so that allows us to overlay it on our file. So I'm just going to pick a different kind of file, which is a vector file. So this is essentially a bunch of features or polygons that show the different water bodies in Africa. So I have this crop data that shows me the yields for maize in a certain year, and I have this other file that shows me all the water bodies in Africa. So I'm trying to match it up and see if there's something, if I can get some interesting correlation to that. Yeah, for it to be better than that. All right, and the one thing that we're still working on is actually integrating search into the HUBzero interface itself. So all this data all the metadata is actually being indexed into Solar, but there's a general Hub search interface available here. We're hoping to have project files also show up there, but that's still in progress. So I can actually show you our Solar instance real quick. So search core and it's not replication query. Let's see. So the files, those are polygons that I'm sort of uploading right now. You can see it has a harvest mean and a depth that was created minutes back. And it also has the geospatial bounds, and so that can be used there for GeoSearch, which Solar supports. I guess while we're waiting for this to be uploaded, I can take more questions. Yes?
Are you using multiple zones or only one?
No, it's a very simple setup. It's just one zone and just a single service account, so we don't have accounts based on the hub users. It's just one service account, but then all the access control is through the projects. So you can only get to the project's collections